Our next keynote is Silicon Motion, and the topic is going to be energy efficiency and data efficiency in the next cloud-to-edge AI era. With us today are two executives from Silicon Motion, Robert Fan, who served as Senior VP of Global Sales. He's in charge of Silicon Motion's worldwide sales operations, field app engineers. He also oversees corporate marketing, communications, and public relations. He has over 30 years of sales and marketing experience and joined Silicon Motion in 2013, served as the president of Silicon Motion USA until 2023. And prior to Silicon Motion, Robert has served as in executive management roles at Spansian, IDT, StackTech, and two venture capital-backed startups. He also spent over 9 years at Intel in sales, marketing, and management positions, and was actually a chip designer earlier in his career. We also have with us Gary Adams, Associate VP of Enterprise Marketing and Business Development at Silicon Motion. He's responsible for promoting enterprise controllers and development platforms that accelerate high performance for data center SSD development. Gary has over 20 years in providing innovative leadership for storage products and business solutions addressing market application needs. He has had various marketing and sales management positions at Microchip, Microsemi, PMC Sierra, and IDT. He earned his bachelor's and master's electrical engineering from Cal State Chico. Please join me in welcoming Robert and Gary.
Hi there. Welcome back this year to our SMI keynote. It's great to be here again. Robert and I will be talking today about energy and data efficiency in the next cloud-to-edge AI era. Let's get started. Oops. Before we get started, I have to show this slide. It's mandatory. All right. Taking a quick snapshot of Silicon Motion, we are the go-to-market leader in merchant and NAND flash controllers and solutions. With over 22 years in working with all NAND suppliers, we have differentiated solutions that are provided in data center, PCs, smartphones, automotive, and industrial markets. I think we'd all agree that AI is everywhere. Every element of our lives is being touched by AI today. When you have kids and grandmas using the common use of ChatGPT, there's examples of how AI touches us. AI is increasingly providing work efficiency, providing personalized assistance, safer driving, and more convenient living. Now, at SMI, we see that storage has a critical role to play in the AI ecosystem. It is clear that we need to focus on how flash is managed, and it'll be an unsung hero for enabling faster, more efficient, and more secure AI. AI generates tons of data, and so large capacity SSDs are required. AI compute needs to be fed data quickly, and so data efficiency is key. AI consumes an unprecedented amount of power, so performance per watt becomes the focus benchmark across all markets. And lastly, AI privacy is more important than ever as AI moves to devices. Personal data needs to be secured from consumer AI edge IoT, to data center core. So, kind of breaking into some of these areas and talking about high capacity, SMI has been the collaboration and innovation partner for QLC enablement. Leading the development with the first PC QLC SSD, SMI continues to pioneer the way with the market's first enterprise Gen 5 QLC SSDs. And going beyond nearline HDD replacements, we're now hearing that AI demands need high performance, high capacity SSDs that are uniquely enabled with larger die NAND. However, new innovations is required when we move to increasing number of NAND layers to provide cost-effective, low-power solutions in these high-capacity SSDs. SMI's 8th generation of NAND Extend technology enhances QLC reliability and reduces error correction latency. In addition, we're adding channel processor hardware engines to accelerate NAND machine learning. This flexibility enables stable performance and reliable data protection across storage platforms. Now, looking at data efficiency. I think we've all seen this week the AI data pipeline, and it's a comprehensive network to be able to describe the various stages from collection to deployment. It ensures that data is prepared and processed and utilized effectively for large language models and machine learning. SMI is digging deeper into what is needed to be done within the SSD to maximize data efficiency, maximize or minimize total system power while reducing completion times. In addition, we're also focusing on how more efficiently to maximize the potential of NAND within the SSD. So optimizing where data is placed with the new data placement technologies like zone namespaces and flexible data placements, we can shorten latency, improve performance, and endurance of AI-specific SSDs. Now, let's move to the consumer edge. Okay? Computation and data movement consumes a large amount of energy. And dissipating heat for power-hungry AI computation is a challenge, especially on AI devices. So power budgets are squeezed by NPU and large DRAM pools, so simultaneously the cost of power dissipating materials, especially in ultra-thin devices, is high. So SSD performance race in itself has to be rethought. And so merely increasing data performance or transmission speeds and focusing on low power, we need to also focus on lower power consumption and how do we dissipate these parts. So we are focused now on performance per watt as a key benchmark. When we only consider performance comparisons under the same power, and they're very meaningful. How does SMI do this? We first start from an ASIC design by doing power islanding, frequency scaling, and looking at how we can enter and exit very quickly from low power modes. We also leverage more advanced fab processes, as well as we have lower power LDPC architectures that use intelligent on-device training to increase performance while reducing overall error correction possibility. And lastly, we overlay advanced firmware that does power scaling, performance monitoring, as well as data placement. And lastly, privacy is key for on-device AI. SMI's on-device tampering resistant and data encryption engine and hardware help protect personal data in storage. Our end-to-end data protection and controllers prevent hacking, and we continue to make investments in enterprise focus on root of trust, Calyptra, and post-quantum cryptographically technology. I've tried it 5 times, sorry guys. All right, so from an introduction perspective, SMI has a comprehensive AI strategy going from enterprise core to edge, as well as AI consumer edge personal devices to AIoT, as well as automotive markets. These all touch the human experience. So let's discuss what we're doing specifically in data center to start. MonTitan is our enterprise product SSD development platform. It provides purpose-built firmware, hardware, and ASIC technologies that work synergistically to address customers' needs. MonTitan is composed of an SSD controller ASIC, standards-based reference hardware designs supporting EDSFF and legacy form factors, as well as a layered firmware stack supporting both standard NVMe and host-based FTL usage models. The core of what we've launched today is the SM8366, which is our high-performance ASIC. It has a true dual-ported architecture targeting both enterprise storage and data center. It has 16 channels running at 2400 mega transfers and uses a DDR5 DRAM interface. It provides the industry-leading, blazingly high performance. And as we know in AI, performance matters significantly. And we're providing a 20 to 30% up on the comparative off-the-shelf controllers for performance, and this is key for graphical neural networks and large language models for training. The MonTitan platform architecture is firmware defined and hardware accelerated. Going beyond high-performance data plane, it focuses on control plane efficiencies and coherencies between hardware and the processing elements, which is perfect for extending AI applications into the SSD. And this week we've heard a lot about that data pipeline. In more detail, just to describe what we think is going on within the SSD, we talk about ingest. Basically, ingesting as we go out and fetch from external sources, potentially all the way down to IoT devices, provide some unstructured and store that unstructured data within the SSD. In preparation stage, data is modified and stored in a format that's convenient, and the feature extraction and model exploration is done, prep. And then in training, the GPU starts taking control and selects batches of input data, and the model walks back and forth randomly until we build up to an AI model. However, this is in the area where we see significant concern as if we do checkpointing and potentially have an issue of restore, we have risk the GPU cycles can become idle or not highly proficient in what they're doing. So we need to focus on that significantly. And inference is when we get running with either current or new live data, and once the processing is complete, you can use that AI product and put it in devices such as cars or phones and anything in your personal experience. So, a lot of words, simple graph, what's the point? The key takeaway is that I/O workloads along the AI data pipeline have completely different attributes in terms of access type, operation type, and access size and concurrency. And so for data center or large enterprise organizations, the storage for the entire AI pipeline can be implemented in a central and unified data storage. The challenge for our high-capacity SSDs is the potentially multi-tenancy environment, as the same data can be attempted to be accessed by different stages of the pipeline. This is commonly referred to as the I/O blender effect. So one of the technologies that we propose to help mitigate the I/O blender effect is flexible data placement. This happens, so with the I/O, what the FDP does is eliminates the read and write requests when a read and write requests go to a storage system, results in mixed or unpredictable I/O, leads to the overall reduction in storage performance. FDP can mitigate that on writes. And when we overlay our proprietary performance technology, we allow a host, either AI server or AI storage server, to define a QoS set that configure QoS sets dynamically for specific applications running on specific workload in the AI pipeline. And just from a note of reference, our performance shape technology can shape hundreds of workloads just in one Gen 5 SSD. So what we're proposing, is multidimensional SSD performance. So we start with the industry's highest performance PCI Express Gen 5 SSD. We incorporate FDP to optimize direct data placement in our QLC SSDs to maximize write. We provide SMI patented performance shape technology to optimize QoS per each workload. And we're trying to remove and isolate the concurrency issues with the multi-tenant environment. This assures that GPU performance on streams of data is maximized at each individual GPU. So today, on the data center side, we're announcing our multi-dimensional performance SSDs for AI storage to accelerate the AI storage pipeline efficiency within high-capacity SSDs. So we'll be starting our first products with the high-capacity QLC SSDs up to 128 terabytes, supporting U.2, E3.S, and E3.L form factors. Solutions will be launched in 2025. So what I'm going to do is hand over the discussion now to Robert to spend more time in going over our other AI-specific solutions.
Thank you, Gary. Hello, everyone. I'm Robert Fan. You may think of me as the guy who's keeping you away from a very important event. It's called lunch. So please bear with me for the next 10 minutes. I'm very happy to be back to talk to you about SMI solutions for edge applications, such as AI PC, AI smartphones, and automotive. In this conference, you've heard of the 3 parameters that are critical to AI storage. Do you guys remember what they are? Performance, capacity, and power. I'm going to tell you how SMI solutions are optimized along these 3 vectors for a number of different AI applications. So starting with AI PC. AI PC is not just a small change. It's a big leap in terms of capabilities that will invigorate the PC market. In short, AI is the next killer app in the PC industry. According to Gartner, by 2025, over 40% of the PC will have on-device AI capabilities. And by 2027, more than 60% of the microprocessors in PCs will have built-in AI features. Now, these numbers show how fast AI is going to become a standard part of computing. For AI PC, Silicon Motion is introducing the SM2508, the best data-efficient and power-efficient PCIe Gen 5 controller for client SSDs. The SM2508 offers 3 times better the efficiency than the previous models and uses less than 7 watts. Now, that's an incredible low power for such a performance. And it is the best in class in the industry today. This controller features 8 NAND channels supporting up to 8 terabyte of capacity, and it supports NAND running at I/O speeds of up to 3,600 megatransfer per second, delivering sequential read performance of up to 14.6 gigabyte per second, sequential write performance of up to 13.6 gigabyte per second, and up to 2.5 million IOPS. Now, this is incredible data efficiency at low power. This controller is set to redefine the standards of SSDs in the client PCs. Now, let me talk a little bit more about power consumption, because this is where the 2508 really shines. Usually, when you increase the performance of a controller, you also increase the power. Now, our new controller uses the TSMC 6 nanometer EUV process, along with some innovative power management design techniques to cut the power consumption by about half compared to other PCIe Gen 5 designs. The graph in the chart shows that we are achieving 50% lower power consumption on a 6 nanometer process and delivering higher performance than other designs based on 12 nanometer process. What this translates to is a breakthrough power efficiency as defined by gigabytes per second per watts. The SM2508 controller is not just a little bit better than the competition, it is a lot better. We're seeing a 70% improvement in power efficiency compared to competition. As the chart on the slide shows, the average active power efficiency for our competitor is about 1273 megabyte per watt, whereas for 2508, our controller achieves almost 2200 megabyte per watt. That is a 70% increase. This means that the 2508-based SSDs run cooler, use less power, help notebook batteries run longer, while delivering top-tier performance. The SM2508 is designed to excel in the age of edge AI across multiple platforms ranging from desktop PCs to notebooks to gaming systems to industrial applications due to its best-in-class power consumption, its breakthrough power efficiency, and its remarkable low power state, as well as data efficiency. For these reasons, major NAND OEMs and module makers are adopting our 2508 in their next PCIe SSD products. Now, let me transition to AI smartphones. Artificial intelligence, and particularly generative AI, will be personalized. And there are no devices that are better for personalized artificial intelligence and generative AI than the smartphone. For this reason, we expect the AI smartphones to proliferate in the coming future. Gartner estimates that Gen AI smartphones will be 65% of all smartphone shipment by 2027. Now, the first versions of AI phones are providing AI enhancements to applications such as photo editing, language translation, and intelligent shopping. The expansion of light LLMs will enable much more AI capabilities that will drive the growth of this device category. In AI phones, both the storage bandwidth and power consumption are the key factors. For you need storage access to the large language models that are fast, but without compromising battery life. So SMI offers our latest UFS 4.0 controller, the SM2756, with impressive performance of read and write sequential performance of over 4,000 megabytes per second, while offering 1.5 times lower power compared to UFS 3. It also contains enhanced ECC engine that will enable twice the life cycles of the flash, and will also support up to 2 terabyte capacity. Compared to UFS 3, the SMI 2756 controller provides sequential read speeds that are twice faster and the random speeds that are 1.5 faster. Both of these parameters are important for AI applications on a mobile phone. With this performance, the time it takes to load a 3 billion AI large language model will be under half a second. Furthermore, the 2756 also exhibits excellent power efficiency. The power efficiency of this controller is going to be about 1.65 times greater than that of UFS 3, resulting in 56% power savings when loading a 3 billion parameter AI model and a 40% power efficiency and savings in the daily operations of a smartphone. The SM2756 will usher a new generation of AI smartphones to the market. Okay, now let's quickly switch to automotive. Smart cars are becoming more integrated, intelligent, and humanized. This is enabled by the software-defined vehicle technology, or SDV, which relies on a central electronic architecture in a car. Gartner predicts that by 2031, software-defined vehicles will be 90% of the cars shipped, driven by the centralized architecture. In a centralized architecture, a high-performance CPU will control all the major functions of the car. Therefore, artificial intelligence becomes more meaningful and important because it can help enhance the applications such as navigation, autonomous driving, safety and security, and energy management of the car. A high-performance SSD is also critical to enable a fast access time of the data by the CPU so that it can respond faster to those applications. Our SM2264XT80 is the world's first PCIe automotive SSD controller. It supports SROV, which stands for Single Root I/O Virtualization Function, and also supports up to 8 virtual functions, enabling the CPU to offload the task of accessing the data to the storage so that it can service other applications. The high performance of this controller also helps reduce the latency and the reaction time for all applications. And this is critical for a software-defined vehicle architecture. Our 2264XT80 belongs to a family of SSD, UFS, and eMMC solutions that Silicon Motion offers to the automotive industry. Our products are ideal for many different applications in a car, such as ADAS, infotainment, central computing, and our solutions are certified according to the most rigorous automotive certifications. Okay, so I'd like to summarize the talk today from Gary and I, that SMI delivers solutions that are critical for AI storage. And we offer a comprehensive product line targeting various AI applications, ranging from data center to enterprise for devices that we optimize for power efficiency, data efficiency, security, and capacity. Now, all the products that we talked about are exhibited in our booth, booth 315. We invite you to go visit our booth, interact with our colleagues there, and I hope that you all have a great lunch, great rest of the day, and a great rest of the conference. Thank you.